Good morning, class. Today we'll continue with the chapter Data Handling. Today we'll learn about bar graph, double bar graph, and learn a new topic, that is probability. So let's start with bar graph. The information collected can be represented in the form of pictogram or bar graph. This is a form of representing data visually. A bar graph is representation of numbers using bars of uniform width and length of bars depend upon the frequency and the scale you have chosen. In the case of bar graph or bar diagram, bars of uniform width are drawn horizontally or vertically with equal spacing between them, and the length of each bar represents the given number. Let us take an example. Here we have a data about students ABCD and their mathematics marks. So here we have to represent a simple bar graph. In this, firstly we'll draw all the horizontal lines and a vertical line. Secondly, on the horizontal line we will write the names of students, and the vertical line we'll write the score of maths. Okay, Next, the scale taken for 1 unit is 5 marks, and in a simple bar graph, only the scores of one subject is marked. Same data can be represented by interchanging the items on horizontal and vertical axis. The height of the bar graph represents the score of a student. Now let us learn about double bar graph. Double bar graph is a way of representing two datas at the same time. A bar graph represents in one set of data, for example, scores of students in maths, and whereas when we have to represent more than two, the double graph represents two sets of data in one graph. For example, score of maths and Hindi. So both of them are represented in the same graph, right? For example, let there be 4 students ABCD. The total marks of both Hindi and marks test is 40. The double bar graph can be obtained as follows. Here we have the 4 students and their marks in maths and Hindi, right? So let's firstly draw a horizontal and a vertical line. Yes, the next step will be that on the horizontal line we will write the names of students, and on the vertical line we can write the scores of maths and Hindi. On the other hand, if we want, we can do just the opposite also. But in this case, we'll do in this manner. Next, we'll determine the scale. So in this case, we have taken 1 unit as 5 marks, right? So according to the highest and the lowest mark, you can determine how much marks or unit for 1 unit, how many marks you can represent. In a double bar graph, and as I have told you already, that you can interchange the vertical and the horizontal axis. The height of the bar graph represents the score of the student. So here we have represented the data in the pictorial form, that is the double bar graph. So here both the marks of students in both maths and Hindi are visually represented. So you can see that the student C has both equal marks in maths and Hindi, while the student D is performed well in Hindi but not in maths. And talking about student A, he has performed good or okay or average in the subject maths, while very poor in the subject Hindi. Similarly, talking about the student B, he has scored more in maths than Hindi, right? So visually we understood the data in a simple manner, right? Now let's move ahead. Now let's begin with our exercise 3.3, okay, in which we have questions related to bar graph and double bar graph. So here we go. So let's begin with the exercise. Here's the first question. We have a bar graph which represents the number of students on one side and the pets they own. Over here, the very first question is which is the most popular pet, right? So here from this bar graph you can understand that cat is the most popular pet, while the second question is how many students have dog as pet. So as you can see the bar graph and understand that the number is 8 students who have dog as pet. Okay, now let's move to the second question. So in the second question, we have a bar graph which represents the number of books that were sold by a bookshop in specific years, right? So seeing the data, the first question is how many books were sold in 1989? So see the bar graph specifically for 1989 and we can say that the number of books were around 180 books, right? From now let us see 1990. So over here also it is not exactly at 500, a bit lesser than 500. So we can say around 475 books were sold. And now in this case of the third question, that is in the year 1992. So the bar graph is little more than 200. So we can say around 225 books were sold in 1992. Now let's come to the second part. In which year we have 475 books sold? About 225 books sold. So 475 we have already said it is in the year 1990, and 225 we have already said it is in the year 1992. The third part says in which year were fewer than 250 books sold. So the answer is 1992, which is 225 books, and 1989 is also lesser than 200, around 180 books. Now let's go to the fourth part. It says, can you explain how many would estimate the number of books sold in 1989? It is of course by reading the graph we calculate that 180 books were sold in 1989, right? Now let's move to the third question. The third question says that the number of children in 6 different classes are given below. Represent the data on a bar graph. So here we have the data. Now the first one is, how would you choose a scale? Okay. The second question says, which class has the maximum number of children and the minimum, and find the ratio of students of class 6th to the students of class 8. Right? Now let's see at the solution. So to draw the bar graph, firstly we draw the horizontal and the vertical line. In the vertical line we represent the number of children, while in the horizontal line we represent the class, right? So accordingly we will draw the bar graph and we will select the scale. So over here the data is ranging from around 90 to 135. So we'll begin from 0 and keep the scale as 10, right? So the answer of the first part will be the scale of 1 unit is 10. Okay, so 1 unit is equal to 10 children. Now the answer of the second part. Which class has the maximum? It is class 5, and the minimum will be class 10, right? Now let's go to the third part. Here we have to find the ratio of the student of class 6 and class 8. So here the answer will be 120 by 100. So we'll simplify and write it as 6 by 5, and the ratio will be written as 6:5. Now let's move to the next question. That is the fifth question. Okay. So in the fifth question here we have this data, that is about how many people are watching and participating in sports in a colony. Now let's see at the question. So the first part is to draw a double bar graph using the specific data, and then the first question, what do you infer from the bar graph, then which sport is most popular, and then most preferred watching or participating in sport. So what is more preferred? Now let's go to the bar graph. So we can draw the bar graph by drawing a vertical and a horizontal line specifically. Now in the vertical line we'll represent the number of people, and while in the horizontal line the sports like cricket, basketball, and swimming, hockey, athletics. Okay, we'll be using 2 bars for one specific sports. For example, in the cricket, we'll firstly represent one bar will represent how many people are watching, and specifically mention which color is for watching and which color we are representing participants, right? So specifically we'll draw the bar graph, the double bar graph, and then now let's answer the first part. That is, what do you infer from the bar graph? So we can say that the double bar graph represents the number of people who like watching and participating in different sports. We may also find that the most people like watching and participating cricket, while least number like athletics, right? So this is what you infer. Now the second part says which sports is most popular. So you have already seen that the most popular sports is cricket. So the answer of the second part is cricket. Now the third part, which says which is most preferred, watching or participating in sports. Yes, watching is more preferred than participating. That's what you infer from the data. So we have done 1, 2, 3 and 5 questions from your exercise, and fourth and the sixth one you can try it for yourself. You can cross-check the answers from the PDF. Now let's move to the next section, that is chance and probability. So let's now watch this video and get a better understanding about this topic.
We have come across such statements like this: there is no chance of Australian team winning today, or there is no chance of raining today. Let us try to understand the meaning of chance with few more examples. The sun sets in the east. The weight of hippopotamus is about 2 kgs. If you draw two rectangles, one small and one big, then the area of the larger rectangle is more than the area of the smaller one. If you drink water from a glass, the quantity of the water from the glass will decrease. Australia winning the next test series. If we look at these statements, the first and the second case is impossible, while third and fourth statement is true and certain to happen. But for the fifth statement, we say it may win or may not. Similarly, if we toss a coin, we will either get a heads or a tails. The probability of getting a head or a tails is 50-50. It is just a matter of chance that we get either of these in each throw of the coin. Similarly, when we toss a dice, there is chance or probability of getting 1, 2, 3, 4, 5 and 6 in any number of throws. Thus, we can say that probability is a way of describing how likely it is that an event will happen. Probability can be expressed in the following ways: equally likely probability, likely probability, unlikely probability, equal likely probability. There are 2 flowers in a vase, one red and one yellow. Since there is one of each, the likelihood of picking a red or a yellow flower with your eyes blindfolded is equal. Therefore, the probability of picking a red or a yellow flower is equal. There is one yellow flower out of 2 flowers. Therefore, the probability of picking yellow flower is 1/2. Likely probability. Let us have 3 flowers in the vase, 2 red and 1 yellow. Since we have more red flowers, the probability of picking out a red with blindfolded eyes is more than or more likely that of picking the yellow flower. The probability of picking 2 red flowers out of 3 flowers is 2/3. Let us see another example. Here we have 10 balls. Out of 10 balls, 4 balls are green in color, 1 ball is red in color, and 5 balls are yellow in color. The likelihood of picking a yellow ball would be higher. Thus, the probability of picking yellow balls with blindfolded eyes is 5 by 10. Unlikely probability. In the same example of balls, it is less likely that you would pick out a red ball since there are more yellow and green than red. The probability of picking out red ball is 1 by 10.
I hope you understood the basic concept. It states that probability is equal to the number of ways an event can occur divided by the total number of possible events, right? So now let's move to the next exercise, that is 3.4. So let me begin with the first question. Tell whether the following is certain to happen, impossible, can happen, but not certain. So look at the last option, can happen but not certain. So this is the third option, which is a bit confusing. Not certain means not sure. Okay, so let's begin with the first one. You are older than today than yesterday. It is sure to happen. The second one, a tossed coin can land head up. It can happen, but it's not always that it will happen. It's not sure, right? Now the third one, a die which tossed shall land up with 8 on top. It is impossible because the dice has only 6 options, 1 2 3 4 5 6, so it is impossible. Now the next one, next traffic light seen will be green. Can happen, but it's not sure. Can be red or yellow also, right? Next one, tomorrow will be a cloudy day. It can happen but not certain. So let's move to the next question. There are 6 marbles in a box with number 1 to 6. What is the probability of drawing marble with number 2? So you know the formula, that is total number of ways divided by the total number of possible events. So here the total number of ways or chance is 1 out of 6. So the answer will be 1 by 6. While on the other side, the probability of drawing 5 is also the same, that it is 1 by 6. The next question says, a coin is flipped to decide which team starts the game. What is the probability that your team will start? So there is only 2 sides in a coin. So the chance of one side coming is 1 out of the 2 chances, right? So the probability will be equal to 1 divided by 2. So we are done for today. Now your homework will be to complete the exercise 3.3 and 3.4 neatly in your notebook. Thank you. Have a great day.